So in Java, we have 8 data types that are built into the Java language. We refer to those as primitive data types. And these 8 types can be broken down into 4 categories. We have the integer types, so these would be whole numbers. We have floating point types, so these would be numbers with a fractional component. We have character data types, so a letter as a character. And there's also a Boolean data type, a true or false value. Well, integer, there's actually 4 data types, 4 primitives that encompass the bigger category of integers. We have byte, short, int, and long. And the difference between them basically comes down to how much data they can store. An int, for example, stores 4 bytes worth of information, whereas a short only stores 2 bytes. Well, something like an int can store really large numbers. Let me see if I can make my make up what the number is here. We got, I think that's billion, 2 billion, over 2 billion, 147 million maximum value on an int, and negative 2 billion and some change minimum value on the int. Whereas a short, since that just stores 2 bytes of information, its maximum value is 32,767, whereas its minimum is negative 32,768. Obviously, since a byte has even less space allocated to it, it stores even smaller numbers, positive 128, negative 127. And a long, given that it stores in 8 bytes of memory, you can store rather large numbers in a long. Whereas floating points, yeah, they're different in that a float is 4 bytes and a double is 8 bytes. But we should think about the main difference between these as being their precision. A single precision float can start introducing floating point errors probably at about 6 or 7 decimal places. Whereas a double or a double precision floating point, you start seeing problems with at about the 15th decimal place. So if you're doing a lot of math and that math is occurring at the decimal place down in the decimal area, maybe you want to work with doubles instead of floats so you don't have floating point error kicking in. There's actually another thing in the Java libraries called big decimal that has an arbitrary amount of precision if you really need to worry about that. So float and double, also data types. They have a max and a min value associated with them. Float is 32 bits and double is 64 bits. Character. A character is stored as 2 bytes, and it's actually stored as an integer. So every character, every letter has an integer that represents it. Well, you may be familiar. Let me go ahead and bring up Google here. You may be familiar with the ASCII code charts. Let me go ahead and just load one of those up so you can get a feel for that. In the world of ASCII, it's awfully small. Let me see if it brings up a larger page. Oh, redirect. Here it comes, I think. There we are. In the world of ASCII, we have, again, numbers associated with letters. And so I always remember that the number 65 is associated with the capital letter A, whereas the number 90 is the capital letter Z. And when I say 65, I mean the base 10 decimal number. In the world of hexadecimal, 41 would be the hex value to represent that capital A. Well, ASCII, that goes up to 127 what we call code points. So they have 127 numbers that represent various letters. And you can see all the capital, all the lowercase English language letters, a number of the symbols that we have on our keyboards and numbers, and also other things that like the tab is 9 and the line feed that is 10 right here. So a lot of things you use day to day, those have numbers that represent them. There's even extended ASCII that goes up to 255, 0 through 127 for basic ASCII, and then up to 255 for other characters. Maybe things that are a little more specialized, like the tilde symbol or the cents symbol, for example. Those would be in the extended ASCII set. Well, those are pretty limited. Oh, here's extended ASCII on that same page. We see some more going from 128 to 255. There's a 1/2, the N with the tilde above it, the Enya there. We have other symbols it looks like we're running into. But there's only so much you can do here. Let's say you wanted to insert in a Chinese character or an Arabic character. Well, ASCII, extended ASCII, there's just not enough code points. Those 255 numbers, there's just not enough space for all the characters that are out there. And so we have something, instead of ASCII, we have something called Unicode. If I go to unicode.org, we'll see that this is a standards body that maps out numbers to letters. That's, in essence, what they're doing. But since we have lots and lots of letters in all of our languages, we need to have enough space to map that out. And so Unicode goes with 16 bits, with 2 bytes. If you're going with 2 bytes, then you have 65,000 plus code points you can work with. Whereas if it was just a single byte, you're limited to 255 characters, 255 code points. So Java uses Unicode 2-byte characters, 2-byte character codes when it does its work. Let's give you a quick peek at some Unicode. I'm going to go out to the code charts over here at unicode.org in the upper right-hand corner. And we can choose, well, I'll start with basic Latin. We'll see that the first few code points are actually matching up with the ASCII character set. So for example, the character 65 is capital A in ASCII as well as in Unicode. Here it comes. It took a little bit. And so let me find my capital A. Well, they map these up in hexadecimal. So 0041 is capital A, and that maps up to 65 if we're thinking of it as a decimal number. Well, so the good news is Unicode builds on top of ASCII. You don't have to relearn what your mappings are if you already know those first ones. But there's other languages. Look at all these different languages that are out here that have code points for them. And so perhaps you have a Greek character that you're trying to work with. And so we'll go ahead and click on Greek, and I'll make my way down to the character points here. And maybe we need to put the delta symbol in our document somehow. 0394, that is the character code for that triangle, that delta symbol that we have. You don't do this a lot. I mean, normally whatever you have on the keyboard is perfectly fine. But there might be scenarios where you need to use a character from another language. It's just not on the keyboard. You want to pull it in. Here's how you can represent that as a character code. I actually use something like this. I have a background in working with circuit board testers. And we had the symbol, the omega symbol for ohms, 03A9 here, that we included in one of our user interfaces. And so we had that as a character. Keep in mind, though, if you want to display some of these characters, you might need to have the right font installed on the system for these to be displayable. Sure, Java can store them, but if you can present them, that has a lot to do with what your system can do. Okay, so that's Unicode, unicode.org. We have code points. We're matching numbers to letters. And char builds on Unicode, and it's a 16-bit number. And finally, we have a Boolean data type, and it represents either true or false. All lowercase true, all lowercase false. Java, we don't use 0 or 1 for true and false. We don't do capital letters for true or false. It's all lowercase for each of them. Notice also that byte, short, int, long, float, double, char, Boolean, all of these primitive data types, all 8 of them, start with a lowercase letter. They're built into the Java language. Each has a minimum and a maximum value, and we'll talk more about the default value on the next page. Before we wrap this page up, though, I guess real quick, a few questions that are down here in the Investigate section. So answer these for yourselves. If you had to store a person's middle initial, which data type would you use? Let's say you needed to store the length and width of a room in feet. What would you use for the data type there? How about the national debt? What would be a proper data type for that? And finally, the current year. What data type would make sense for that?